myself Dr. K. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering. It is an autonomous institution, Dundigal, located at Hyderabad, India. Today's topic is problems on degrees of freedom. In previous classes, we covered what is the degrees of freedom and degrees of freedom formula for a body when it is located in a space. Now, in kinematics of machines, we study plane mechanisms. For plane mechanisms, what formula we have to use? That formula is Grubler's criterion. In some of the textbooks, it is mentioned as Kuchbek criterion. It is modified. Grubler's criterion is Kuchbek criterion in that the higher pace h equal to 0. So here we are going to use the formula and finding out the degree of freedom of a plane mechanisms. In this session, we are going to solve only degrees of freedom, how to calculate degrees of freedom for various plane mechanisms. So let us begin. This is the 4-bar mechanism. This mechanism is fixed at links O2 and O4. Those are considered as fixed links. The fixed links are always considered as the same group. That's why it is only link 1. Now it is the link 2 and link 3 and link 4. There are 4 links are there. So number of links n equal to 4. And what is number of lower pairs? So lower pairs means the contact between two elements is a surface contact or area contact, then that pair is known as lower pair. Now here the lower pairs between link 2 and 3 is a lower pair, link 1 and 2 is a lower pair, link 3 and 4 is a lower pair, and link 4 and 1 is lower pair contact. So the number of lower pairs L equal to 4. And in this mechanism or in this 4-bar mechanism, there is no higher pairs. That's why H equal to 0. Substitute these values into the formula, that is degrees of freedom F equal to 3 into n minus 1 minus 2L minus H. So n equal to 4 and L equal to 4. Substitute over here, then what is the degree of freedom for this mechanism? That is 3 times 3, 9, 9 times 9 minus 8 equal to 1. The degrees of freedom for this 4-bar mechanism is 1. What is the physical significance? What is the meaning of this degree of freedom equal to 1? That means if we give one input to any one of the link, will result in definite motion of all the links. So there is no, suppose if we give rotary motion to link 2, all links will move in a definite direction. That's why that is the meaning of single degree of freedom systems. So the degree of freedom of this 4-bar mechanism is equal to 1. Next. Now what is the degree of freedom? Second problem number 2. The problem number 2 is here how many links are there? This 5-bar mechanism. The number of links is the 5-bar mechanism. So how many links are here? There are 5 links. N equal to 5. The number of links. What are the number of links are? Here all fixed links are considered as one link. That is fixed link 1 and link 2, link 3, link 4 and link 5. There are 5 links are there. And how many number of lower pairs? Number of lower pairs. Again, lower pair means the motion between two elements of a pair is either surface contact or area contact. Now, link 1 and 2 is area contact. Link 2 and 3, same. link 3 and 4, link 4 and 5, and 5 and 1. So how many lower pairs are there here? There are 1, 2, 3, 4 and 5. The L equal to 5. In this mechanism, there is no higher pair. What is the meaning of higher pair? The contact between the links is either line contact or point contact. Then that pair is considered as higher pair. Now H equal to 0. Now substitute these values in the formula of degree of freedom, that is 3 into n minus 1 minus 2l minus h. That is 3 into n minus 1, that is 5 minus 1, 2 times 5 minus h, that is 3 fourths 12 minus 10 minus 0, that is 2. The degree of freedom for a 5-bar mechanism is 2. What is the physical meaning? So if we give 2 inputs to any 2 links are required to yield definite motions in all the links. So that is the meaning here. That is the significance of degrees of freedom. 2 inputs to any 2 links are required in order to yield definite motions in all the links. Okay, if we give one input motion, one motion, that is link 2, what will happen? Then definite motion can't be obtained in all the links. That's why 2 input are required to any 2 links. Then in order to yield the definite motions to in all the links, that is the degree of freedom for this 5-bar mechanism is 2. Next, how to find out the degree of freedom for the given figure? Again, the number of links in this. Here, how many binary links are there? The mechanism is arranged such that there are 2 ternary links are there. This is also ternary link. I am talking about ternary link. And how many binary links are there? How many binary links? How many binary? 1, 2, 3, 4. There are 4 binary links are there. So let us begin. What is number of links are? What are they? What are the number of links? The number of links are the number of links. How many links are there? There are 1, 2, 3, 4, 5 and 6. N equal to 6. And the number of lower pairs. How many number of lower pairs are there? You can find out the joints that indicates directly. This is one joint, 1, 2, 3, 4, 5, 6 and 7. The number of lower pairs are 7. What about higher pairs? The number of higher pairs are again 0. Substitute again the formula 3 times n minus 1, 2 times L minus H. That equal to 3 times n minus 1, 6 minus 1, 2 times 7 minus 0. Then the equation becomes, what is the degree of freedom? 3 times 5, 15 minus 14. The degree of freedom for this mechanism is again 1. Then again, what is the physical significance? What is the meaning of the system when the degree of freedom equal to 1? So if we give one input to any one link, will result in definite motion of all the links. It results in definite motion of all the links. That is the meaning. So the degree of freedom equal to 1 for this mechanism. Okay, let us solve. How to solve degree of freedom for this mechanism? So the number of, again, find out the number of links. The number of links in this mechanism, all fixed links, consider whenever this type of figure is given. How to solve? Let first give numbers to the links. The link fixed link 1, all fixed links are 1. Now it is link number 2, number 3, link 4, 5, 6, this is 7, 8, 9, 10, 11. How many number of links are here? N equal to 11. Okay, how many lower pairs are here? So the lower pairs here, there are two. How many number of lower pairs are here? The lower pairs are 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, 10 and 11. Plus, now understand here. So 11 we are considering, these lower pairs are considered as binary joints. So there are certain links, there are ternary joints also there. So this L is nothing but number of binary joints. Now, why I said 11? No, this 11 includes, there are two ternary joints also there. So how many ternary joints are there? We have to find out. So at 3, there are how many ternary joints are there? How many binary joints? The total number of total number of binary joints are required. Here, please pay attention very carefully. The binary joints are, this is B1, this is binary joint B2, B3, B4, and it is binary joint B5, B6, B7. Okay, there are 7 binary joints. Okay, next 7 binary joints, 7 number binary. And how many ternary joints are there? Let us see here. This is one ternary joint T1, this is T2, and it is 1, 2, 3 T3, and again it is a T4. So 7 binary joints, 4 ternary joints are there. So we want L indicates in this formula total number of binary joints. What is the total number of binary joints? L equal to 7 binary joints. One ternary joint equal to 2 binary joints. That means 4 times 2, 8. So 7 plus 8, the 15 total number of binary joints. Okay. Now what are the higher pairs are? Higher pairs H equal to 0. This L for number of lower pairs. But again, if you go for subclassification, binary joints are required. So total number of binary joints in this problem, there are 7 binary joints and 4 ternary joints are there. Alright. So that's why total one ternary joint equal to again 2 binary joints. 4 into 2, 8, 7 plus 8, 15. Now substitute over those values in the formula of degrees of freedom of a planar plane mechanisms, that F equal to 3 into n minus 1 minus 2L minus H. What is n equal to 11? 3 into 11 minus 1, 3 times, that is 30, and 2 into L, 15, that is 30 minus 30 is 0. So when the degree of freedom for this mechanism is 0, what is that meaning? Degrees of freedom for this mechanism is 0. That means it is no transferring of motion. There is no motion in this, even though if we apply the motion. Now, this type of mechanism is known as structure. If the degree of freedom equal to 0, then that mechanism is called as, or is known as, locked system or structure. Now, similarly, how to find out the degrees of freedom for this mechanism? As usual, the number of links. We know the number of links, n equal to, how many links are there? How many links are there? Here, 1, 2 mentioned, that is the link 1 and 2 are relatively joined here. Link 2, 3, 4. This 2, 3, 4 indicates three links are joined, that is a ternary. This is binary. This is binary joint. B1, B2, B3, B4, B5. So how many links are there? The links are 1, 2, 3, 4, 5 and 6. N equal to 6. N equal to 6. Okay, how many number of lower pairs are there? Number of lower pairs means number of binary joints are there. The number of binary joints equal to binary joints plus number of total number. Again, ternary joints you have to add it. Now binary joints, how many are there? Total binary joints are 5 binary joints plus 1 ternary joint. So 5 binary joint, 5 plus 1 ternary joint equal to 2 binary joints. That equal to 5 plus 2, 7. N equal to 6, L equal to 7 and H equal to 0. Substitute this number of links, number of lower pairs and the value of number of higher pairs in the formula of degree of freedom, that is F equal to 3 into n minus 1 minus 2L minus H, where n equal to 6 according to the values are observed from this mechanism. N equal to 6 and L equal to 7. Now substitute, if you after getting substitution, 3 into 6 minus 1, 3 5s minus 2 7s, then 15 minus 14, that equal to 1. The degrees of freedom for this mechanism is equal to 1. What is the meaning? Again, what is the significance of degree of freedom equal to 1? That means if we apply any one input to any one of the link, the remaining links can be moved in a definite direction. That is the meaning. Now, further examples of degrees of freedom. The further examples were given here in order to practice more and more, because it's very, very important topic for internal and end semester examinations. Now, I am going to take the problem that B case. So what is here, we considered higher pair is taken into picture. So now here, what are the links? The number of links are 1, 2 and again 3. N equal to 3. And what about L? The number of lower pairs. The number of lower pairs, L equal to 2. What is L equal to 2? The contact between fixed link and 2, this is one lower pair. The contact between link 1 and 3, another lower pair. That is L equal to 2. Whatever higher pairs. High pair means if the contact between the links of a pair is either point contact or line contact, then that pair is called as higher pair. The contact between link 2 and 3 is higher pair contact. That's why higher pair is only single contact, that is 1, H equal to 1. Substitute these values of number of links and number of lower pairs and higher pairs in the formula of degrees of freedom, that is F equal to 3 times n minus 1 minus 2L minus H. Then the degrees of freedom can be observed as equal to, that is equal to 1. F equal to 1. Again, what is the physical significance? Degree of freedom equal to 1 is if we apply any definite input motion to any one of the link, all the links move in a definite direction, in a definite motion. So that's why the degree of freedom equal to 1. Now, similarly, if we observe the figure C, the number of links equal to 3 and number of links, number of lower pairs equal to 2 and higher pair contact equal to 1. Here, very important is that this link 1 is welded here. That means there is no relative motion. This complete link is considered as one link. Okay, even though two parts are there, but there is no relative motion between those two parts. It is completely welded. That means completely constrained, considered as one link. That is another concept. Now, the fixed links, all fixed links are considered as number 1, and link number 2, this is link number 3, because this total part, now n equal to 3. Now what are the lower pairs are? The lower pairs are this link 1 and 2, one lower pair, and link 1 and 3, another lower pair. That's why L equal to 2. What is the contact? H equal to, is the two rollers elements having the contact between two circular bodies. They call higher contact or point contact. So that's why point contact H equal to 1. So H equal to 1, substitute over again n equal to 3, L equal to 2 and H equal to 1 in the formula of degrees of freedom, that is F equal to 3 times n minus 1 minus 2L minus H. Then the degrees of freedom value is observed as 1. So we can understand like that what is the concept of degrees of freedom. Okay. Today in this class, in this section, we'll thoroughly understood how to calculate of degrees of freedom of various mechanisms in a systematic manner in detail. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.